Thanks very much. This paper is a joint with Mark Wilhelm, and I'll thank the John Templeton Foundation. This is work that stemmed from a project where Templeton had supported us collecting a bunch of tax data on schools and seeing how schools responded to policy. We stumbled across a kind of remarkable data set and an unusual policy. So when you put interesting data and interesting policies together, sometimes something interesting happens. And so the policy that we're going to focus on here is a policy related to the price of charitable giving, in particular the tax price of charitable giving. So very often when an individual gives $1 to charity, the amount of consumption they forego is less than $1. Why might that be the case? Well, one example is, of course, matching. And another would be from tax incentives in the United States and elsewhere. There are important incentives to give through the tax code. This latter feature is very expensive in the US and elsewhere, involving tens of billions of dollars a year. You might wonder, does it pay for itself? Is it worth it? Does it actually help increase charitable giving? That depends upon how responsive people are to price, so that's where we come in here. There's a large literature on how responsive donors are to price, and despite the size of this literature and the fact that it's several decades old, it is completely uninformative for tax policy. At the moment when the federal government makes projections about this, they simply use several different estimates, since there is no estimate that the literature suggests that they can take for projections. Certainly in the last years, there's been a lot of great studies on field experiments or laboratory experiments on responsiveness to price. But a key finding from that literature is that the context in which price varies can matter a lot. And so that might make you especially cautious about taking results from those studies and applying them to the tax code. So then you might say, well, why don't we just study the tax code itself? That turns out to be even more difficult. A lot of the incentives that vary in the tax code for charitable giving depend upon a person's marginal tax rate, but comparing people with different marginal tax rates is very problematic. And so it's a very unsettled literature. At the forefront of this literature right now, I'd say two of the main papers are first by Randolph. He's 20 years old, but still at the forefront. He estimates an elasticity of -0.5. His baseline is 0. And meanwhile, Alton C. Clodfelter, they get an elasticity that's greater in absolute value than -1. Both of these papers use essentially the same data set and essentially the same policy experiment from TRA 86. And they arrive at very different answers. I'm assuming here most people know what an elasticity is. If you don't, I put like a crash course on the board right here. It's just the percent change in giving over the percent change in price. There are a few key values of this concept. If it's 0, then you don't even care about price. 1 is the magic number, okay? If the elasticity is 1, that means this policy is going to raise as much charitable giving as it forgoes in tax revenue. And then infinity, you don't need to worry about infinity. There's no infinite estimates in this paper. So what are we going to do here in this literature to contribute to this literature? Several things. First, we're going to focus on a tax credit rather than a deduction. The magic of a credit is that its value is independent of your marginal tax rate. So it takes this huge problem off the table. The credit we're going to focus on is from the state of Indiana. It's a credit given to people who make donations to institutions of higher education, but the credit is capped. It can go up to $200 for individual filers and $400 for joint filers. That means if you make a donation to a higher education institution in Indiana, the cost to you of donating dollar number 400 is very different from the cost of donating dollar 401. There is a convex kink in your budget constraint. That motivates a kink-based design, and that's what we're going to use today. The value of a kink is that it can estimate a price elasticity with no tax reform, no variation in state marginal tax rates, and in fact, no variation in marginal tax rates at all. Most kink estimates are done using are done to estimate compensated elasticities. But in this literature, probably uncompensated is what you want. And so in this paper, we propose a new kink methodology, one that can directly uncover uncompensated elasticities. And then a final interesting thing that we're going to do today is that we'll estimate this with a sample of about 800,000 donations to a particular school in Indiana. This is all donations to that school, and that includes many extremely large ones. And during the time period of our sample, a portion of the alumni of this school were offered an extremely large multi-million-dollar match. And so we can compare real-world tax incentives to a real high stakes, very large match for individuals in the same context. So let me tell you a little bit about the credit. The credit is for individuals paying Indiana state income tax, who presumably live in Indiana for the most part, giving to institutions of higher learning in Indiana. It's 50 cents on the dollar. So for every dollar that you contribute to Indiana University or Notre Dame, your tax bill at the end of the year falls by 50 cents. So it doesn't depend on your marginal tax rate. That is good for up to $400 of giving. In other words, a $200 credit for married couples. To estimate a kink like this, it's a very data-hungry methodology. We'll need data on people giving to higher education. We need to know where they live so that we know whether or not they pay Indiana tax and face the credit. We need to know where they're giving the money. Just knowing that you're giving to higher education isn't enough because the credit only applies to schools in Indiana. And so what we have done is we have obtained data from a certain university in the state of Indiana. I'm not going to tell you which one it is, but we have data for about a decade worth of time. We have every donation given to this school. And we know the exact date down to the day of the donation, exactly how much it was. We have a scrambled identifier so we can actually follow donors over time. State of residence, if you're an alumni, what your class year was, and whether or not you're married. There's over 800,000 individual donation events. Going up to the year level for a particular person, there's still over 500,000, of which 80,000 are in the state of Indiana. And today I'm going to focus on the $400 kink.
Is this all individual donations or institutional corporate foundations?
Both are in here, but we're just going to focus on, we know whether you're married, and so we assume you're human in that case, and so we're just focusing on that. That's one of the reasons why we do that, actually. So,
I'm not sure I was married.
so here's the basic idea of a kink. The intuition is very simple. If people are paying attention to tax incentives, then right when the tax price changes, people might kind of be bunching up. But if people don't care about that, the tax incentives, then there's nothing special about that dollar value. You shouldn't see anything special happening at that point in the data. Very, very simple idea. Here's a slightly more involved design. Let's skip that. Here's a picture. Hopefully you've at least had intermediate microeconomics if you're in this room. If not, forget the next 5 minutes. So there's like two goods, okay? So this is a good, and then this is like charitable giving on the y-axis, okay? People, when they start out giving, they get a tax break. And so they're on this dashed budget line. It's kind of a steep budget line. That illustrates the idea that if you want to give to charity, you don't have to give up too much. Then you get to this point where the special tax incentives go away. And so all of a sudden you find yourself on this flatter, solid budget line. That illustrates the idea that giving is now more expensive. If you want to give, you're going to lose more of the other good. Okay? So there's a kink. The kink is right there. Now, when Emmanuel Saez came along and developed the kink methodology, here was the thought experiment he went through. He said, suppose that initially everyone's on the dashed budget line forever. In our context, that would mean there's no cap to the credit. People start out on an interior solution up here. Then the government comes along and they say, we're going to get rid of this special tax treatment for gifts above G star. So you go from being on this dashed line to this new solid line. Some people will be at interior solutions here and here. But there's going to be a range of people who used to be at interior solutions who now end up at the kink. Saez says, let's think about the person who is the furthest above the kink initially, who ends up at the kink once the government shows up and caps the credit at G star. That person might look something like this. So they're initially at a consumer equilibrium at B, and now they're down here at the kink. We're going to assume that this person is just barely tangent to the kink here at point A. And that's intuitive. If they weren't just barely tangent to the kink, if there was a non-tangency here, then we could presumably find somebody even higher than this, whose bundle B would be even higher. Okay? Here's the next key insight. If they're just barely tangent here at point A, then you can think of the creation of this kink for this person as a compensated price increase. You can imagine increasing the price of giving everywhere and then raising their income level up until they get to that tangency at point A. It's kind of the same process you talk people through in intermediate micro when you teach them about Hicksian or compensated elasticities. Now, is this a picture of a compensated elasticity? Not quite. We haven't given them quite enough income to get them back to their old indifference curve. That would be point C, right? That's the familiar picture from intermediate micro. So what we have, if we can identify this person B, we can see the jump from B to A. The compensated elasticity is something very close to that. It's B to C. Saez's argument is that B to A in most contexts will be very close to B to C. And so if we can figure out that jump B to A, we'll have a very good estimate of the compensated elasticity. Notice that it will be a little bit biased. A and C aren't quite the same. There's a bit of an income effect that we're missing here. Okay. Slightly more formally, Saez assumes people have isoelastic and more importantly, quasi-linear preferences. With that assumption, you can quickly figure out, based on how much bunching there is at the kink, where B is and then where A is. Okay? And from that, you can back out the elasticity. So that's a great idea. Saez, give him the Clark Medal. He's a great, genius for figuring all this out. But there's a couple problems in our context. First, we're talking about charitable giving. That's a world where public goods and wealth effects are probably very important. We could go from a compensated estimate to an uncompensated estimate, where wealth effects are accounted for, using the Slutsky equation. That's the tool in the toolkit for doing that. But we'd still have this income bias. So in this paper, we propose a second conceptualization of kink estimations that give you uncompensated elasticities. Here's that familiar kink budget constraint that I just showed you before. Saez's counterfactual was, let's suppose that the credit goes on forever and ever, and people start out on a high-up budget constraint here. But there's a different counterfactual. Suppose we just got rid of the credit entirely. Now the relevant budget constraint is this lower one down here. In this counterfactual, you'll have people who used to bunch at the kink who will now go downwards to this new lower budget constraint. Let's ask ourselves the question, who goes down the most? That person might look like this. They've got some solution here at B, and they're just barely tangent to the kink here at point A. And again, if they weren't just barely tangent, we could probably find an even lower B. That is an uncompensated price effect. That's all there is to it. You don't have to assume quasi-linearity. In fact, you don't have to make any functional form assumptions at all. That's non-parametrically identified, and there's no income effect bias to worry about. So by considering an alternate counterfactual, you can actually use kinks to estimate either elasticity. Forget about all that. So with the finite amount of time I have left, I'm going to completely skip over all the technical details of how you actually come up with the numbers based on the bunching. There's also a bunch of caveats that you might worry about. I'm going to completely ignore all of those too right now. Suffice it to say, there's some caveats with estimating kinks, but the kink methodology can account for a lot of these things. Instead, I'm going to skip right to some results. Here's a histogram of giving to this school for gifts between 0 and 1,000. So there's hundreds of thousands of donations in this picture. What should you notice? Well, first, not surprisingly, giving declines. There's lots more little gifts than big ones. Next, there's still some giving going on out here around our kink. And then finally, kind of obviously, you see these spikes at the hundreds. And that makes sense. Nobody gives $399. That's a weird number. 400 is a much better number. So if you're going to do a kink estimation where you're looking for bunching at the kink, 400 here, you've got to take into account the fact that there's going to be just natural round number bunching no matter what. So we can take that into account. That's a standard issue in this literature. A very kind of lowbrow, simple way to think about that is illustrated in this picture. Here we do two histograms. One is the gray bars, and the other histogram are these black bars that are white on the inside. The gray bars are people in Indiana who face this kink at 400, and then the white bars are everybody else, for whom 400 is nothing special. Both groups bunch at 400, obviously. 400 is a nice round number, but clearly there's excessive bunching in Indiana right at the tax kink. So this picture to the naked eye suggests that there is something going on at the tax kink for the people who face it. There is excessive bunching. Now the name of the game is to say, okay, this excessive bunching here, how big is it? What sort of elasticity does it imply? Here are some numbers. The different columns and the different rows essentially represent different sample selections where we're kind of varying the range around the kink for our estimates. These are compensated estimates using the conventional kink methodologies. What do we find? Our compensated elasticities are really small. They're very close to 0, no matter what we do. Okay? So people are not very sensitive to price here. They're somewhat sensitive. These are different from 0, but not very sensitive. Next, we do uncompensated estimates using our new method. Again, here, the rows and columns represent different choices of the sample around the kink. There's these boxes. In each box, you see an elasticity estimate and then a confidence interval below it. What do you see? These numbers are a little bit larger than the compensated ones, which makes sense. The income effect is added in. But they're, again, very small, mostly around 0.2 or 0.3. So we estimate tax price elasticities of around 0.2 or 0.3. That's much smaller than most tax papers, but if you look at the experimental literature, there are a lot of canonical estimates in it. Carlin and List's rough estimate from their AER paper, or Eckel Grossman's lab rebate estimate, that are very close to this, actually. Okay, I've got 2 or 3 minutes left. That's kind of the main result, that with kink methods we get these small elasticities. Now let me just walk you through, in words, a few kind of basic extensions we do that we think are pretty interesting. First, you could ask yourself, what happens if you pretend the kink is somewhere it's not? Well, if you do that, you get nothing. I'm not going to show you that, but that's what happens. Next, our kink estimation is identified in a cross-section, but we actually have a panel. So we can do some exploration of whether intertemporal substitution matters for this group. That's a huge problem in all these literatures. How can we do that? Well, we can look at one-time donors for whom intertemporal incentives don't really matter, as I have figured it out, or as I conceive of it anyways, can't see it otherwise, to sometimes donors and then donors who donate lots of years for whom intertemporal incentives might matter a lot. Turns out that you get the same elasticities for all these groups. If you saw big differences between them, then you really might get worried that intertemporal incentives matter, timing incentives across years matter, but it doesn't look like that's the case here. Lastly, there's the matching gift. So the 1960 class of this school in 2010 was given a $3 million match for donations of up to $250,000, and that match existed for an 18-month period. We know your class, we know the month, and we have all gifts uncapped in this data set. So we can compare the response to the match to the response to the kink, comparing a real-world tax incentive to a very large-scale match for the same population. I'm going to completely skip past the details of how we estimate people's response to the match. It's pretty conventional, not too interesting. And I'll simply show you some of the elasticities. This match was capped at $250,000 gifts. So if we just focus on donations below the cap, we see an elasticity that's actually kind of big. It's negative 0.5, somewhat precisely estimated, but not really. That's a t-statistic essentially for the elasticity. When we look at donations of 100,000 or below, a very similar number, somewhat more precisely estimated. But when we just focus on relatively small donations, by which I mean under $10,000, now we get an elasticity much closer to what I was showing you earlier, okay? And it's still fairly precisely estimated. So in this paper, we use a kink to estimate tax price elasticities. We develop a new kink estimation that we think is especially appropriate in this scenario. We would argue that our results are fairly close to some recent laboratory or field experimental studies, but are much smaller than the standard tax price estimates in the literature. And then finally, we find suggestive evidence that intertemporal substitution is modest. But then finally, that very large donations, such as those above $10,000, may respond much differently to incentives than relatively small donations. And do we have time for a question or two? We do? 2 minutes or 2 questions, one or the other. We have 2 of something. Yeah. Yeah.
So if the colleague with the university whose information you're using were to be sitting here next to you and they were the fundraising strategist or leader, what would they say they took away from this?
Yeah, that's a good question. Definitely that if you're trying to grow your donation pool, emphasizing opportunities for matches here probably is more advantageous than worrying about tax policy. The match elasticities I showed you just now, as is often the case in this literature, ignore the match itself. So if you add that in, then the difference between the match and responsiveness to tax policy is really, really, really big. Yeah, sure.
I'm trying to understand the institutional feature of the credit. This is any higher education, any education charity period?
Higher education.
So we should think that some of these people who maybe gave $200 were giving to their spouse's alma mater also.
Yeah.
So you're kind of underestimating the amount of bunching you might have there.
Yeah, so I mean, it is possible that you might have somebody giving to like 2 schools, and we're going to pick up one of those. We might be able to get at that a little bit with some other data sets and surveys and such.
Do you know if they're married to another alumnus or alumna?
So we do not think we can figure that out. Because that would, of course, yeah, that would be very good. But yeah, we do not think we can figure that out.
Ask the university to figure that out for you?
So presumably they could figure it out. But when they gave us alumni status, you know, they said this is if one person's an alumni, and we said, well, we'd love to know both. And they said, eh. So that's anyway. All right. Well, thanks.